Okay, let's get started on this. I think some of you know these words already. Some of you. Who knows a scalar? Who's heard of scalar before? Yeah? And vector?
Time, loss.
Yeah, time is what?
Loss.
Scalar or vector? Scalar, yeah.
Time.
What might be a vector? Velocity is a vector, yeah. So you know these words. Okay. So what is the definition? A scalar is a quantity. How might we finish this sentence? What's
No direction.
Yeah, and that's it, yeah. Has only magnitude, which is a size, and no direction. So this is a common physics exam question around the world, everywhere. So is a definition you need to know. Whose stuff is that? Oh, okay. You got that? Yeah? Okay. I think we mentioned some examples already. What are some examples here? Time is an example. What else? Say again? Mass, yeah, things like this. My example is if I just said walking at 1 step per second. Is a scalar. However, if I said walking at 1 step per second to my home, that's not a scalar. Why not? It has a direction, yeah. You don't need to write the example down. In fact, you could write your own examples down, which would be better. So you mentioned some examples. We said time, we said mass. What else could we have? Speed. You could say height, length, many things. Many things. In the exam, they sometimes ask you for an example with the definition. Speed is always the famous example. Yeah? Continue? You got that? Yeah? Okay, next now. So how is this sentence completed? A vector is a quantity that has both magnitude and direction, yeah. And our examples, 1 step per second to my home is a vector. However, walking at 1 step per second is not a vector, it's a scalar. What are other vectors you might have heard of before? I think someone mentioned one earlier. Acceleration is a vector, yeah. What else? Somebody mentioned a vector earlier.
Manhattan distance. Is that a vector?
I think that's still scalar. I think. Anything else? Oh, I thought I heard somebody mention one earlier. Begins with a V. Velocity, yeah. Velocity is vector. Acceleration, you said. Force. These are all vectors. The example that they use in the exam, the easy one to remember is for a scalar, you can use speed. And for a vector, as an example, you can use velocity. I'm trying to help you remember. Vector begins with a V, so does velocity. Scalar begins with an S, so does speed. So the two examples are speed and velocity. Okay? Torque. Don't know. Like, it's a scalar, but it also has a direction too, because it can be clockwise or anti-clockwise. So I don't know. If you force me to pick one, I'll say it's a vector, because it can be clockwise or anti-clockwise, I think. But it's, no, but they always give it as a positive. I'll have to check that one. I'm not 100% sure. It's safer to pick a different example in the exam. Right, next. So the two most well-known examples of scalars and vectors are speed and velocities, which I was saying. Most native speakers would say speed and velocity are the same thing, but in physics we know that they're different. So, what exactly is the speed of an object? What do we mean when we say speed? Not quite. Not quite.
A rate.
Rate of what?
For
Oh, more details than that. Yeah? Distance. Oh. Yeah, now we're getting there. So, speed of an object is the change of its distance per time. Or as a formula, distance travelled over time taken. Got that? So it's like a simple little example. 50 kilometers per hour, or 10 meters per second, or 1 step per second. They're all speeds. So for the exam, you'll need the definition. We got the definition? No, it's still right, that's okay. Yeah? Yeah? Okay. Now, velocity of an object. What the heck is that? How is that different to speed? So velocity of an object is... Oh, you're nearly there. There's a special word for that. Displacement. So how would you say this definition? What would we say? Yeah? Oh, go on, give it a go.
Rate of change of displacement.
Why not? Rate of change of displacement per time. Velocity is change of displacement over time taken. But you knew that. You were just too shy to say. Okie dokie. We got that? Yeah? So, for example, 50 kilometers per hour due north, or 10 meters per second to the finish line, or 1 step per second to my homebound, they're all velocities. Now, just to make sure we are really clear, where's my pen gone? Here it is. He starts here, and let's say he takes 1, 2, 3, steps left and 1 step right, and he finishes here. What's the distance he travelled? 4 steps. Okay? But what's his displacement? Yeah, in fact, I would say minus 2 steps. Why? Because it's to the left. If we picture it like this, that would be minus 2, and over here would be plus 2. Okay, so we understand the difference between distance and displacement? Yeah? You've probably seen this before. Okay. So, displacement is a vector because it has a direction. It can either be to the left here or to the right. So, it's also known as the position of the object. I think you should write that down. Example will be the ship is 2 kilometers to the east, or the man is 3 kilometers east of his home. These are displacements. Got that? Yeah. So, terms like homebound or to the finish line, the directions, but they're not very useful. We need to be a bit more precise. So often vectors are given as a magnitude and an angle, which you can represent as an arrow. So you've seen this before. This is how you would draw a vector. The length of the vector is the magnitude, and where it's pointing is the direction, and we call this the tail and this the head. The length represents the magnitude, and where it's pointing represents the direction. So for example, if this is 5 kilometers east, then this one here would be 1 kilometer east, because it's shorter. And this one here would be what? 1 kilometer south. Yeah? Okay, could you draw this picture in your notebook of a vector? Okay, you got that picture? You got the words tail, head, magnitude, direction. Yeah? Okay. Okay. So, this one here, I'd like you to do this in your notebook to practice. So first just draw a compass. And I'd like you to put all of these vectors on your compass. North, south, east and west. Now you might get a little bit of trouble towards the end, but you should be able to do the first few, okay? So I'll give you 2 minutes. I think you can get lots of these. Now look, the biggest one is 5. So if you draw this first as 5, that's A. Then when you draw this one, make sure it's a little bit less than 5. It should be 4/5 of the first one. Okay, try how to draw this. We've drawn these. They get a little bit harder. Yeah, let's have a look. So the second one you should be okay with, for east. So, well, if that's 5, then I would say, well, I don't know, about that is 4 maybe? Who knows? 5 west should definitely be the same. So that is 5 west. 1 south, well, that would just be something like that. Now on to the hard ones. Who knew this one? 30 degrees north of east. You know this one? Yeah? That's it, yeah, that's it. So 30 north of east. So north of east.
Less than 45.
That's it. This, you put the 30 here. 30 north of east. This is east and you go north of it. That's E. Okay. North 30 west. This is north 30 west. It means you start north and go 30 to the west. Now, what about this one? Bearing 30.
It's 30 degrees, so you start
Yeah, and which way do you turn?
to the right.
To the right, very good. This is a bearing. Bearings measure from north and they go around like that. So this one here is 30 as well, is it? Yeah, G.
And it's only 1 meter.
Oh, it's only 1, thank you. So it should be more like down here, shouldn't it? G. That's also 30. And the last one is if I just said 2 meters per second at 30. 2 meters per second at 30. Where's that one? Anyone knew that one?
Same as G.
You would think so because you're not mentioning. But here we need to think about it like mathematics class. When you draw your circle, where do you measure your angles from?
The same as E.
Yeah, same as E. That's it. Yeah. That is H there. Yeah. I was trying to think of all the different ways you can talk about angles. I can't think of any other ways.
Radians.
Well, I mean like in reference to a compass, yeah. Yeah, radians and gradients too. Okay? Yeah, we're happy with that? Let's continue. Vectors can be added together using what's called a vector triangle. Consider two vectors A and B, and you want to add them together. When you add them together, you get the result, called resultant vector, or. And you can do this as shown below. If you have vector A, and you want to add it to vector B, you just stick the tail onto the head here, so the tail of B onto the head of A, and then this is the result, A plus B, here. So I'll show you. Imagine you have A, and you want to add it to B. Then all you do is you put A here, you put B here, and then that is A plus B. And we call that resultant, or. Not too difficult, right? Now, you must know this word, resultant vector, and you must have this picture. This is called the vector triangle. Let's check that I have everybody. Nobody ran away yet. Kai Hong?
Yeah.
There you are. Zach? There you are. Son? That's you. Lynn? That's you. Harry? There you are. Regina? Jeffrey? Dorian? And you're not on my list again. I forgot. I need to print out a new list. What's your name again? Diego. Diego? Diego. Okay, did we draw that? Yeah, we have that? Did you draw that? Yeah. Continue? Continue? Yeah? So, to add two vectors, you must put the tail of one vector onto the head of the other. A vector can be multiplied by a scalar. So, if you multiply a vector by 2, what happens to the vector? Yeah, by how much? 2 times, yeah. So it'll double the length. And if you multiply it by a half, half the length, yeah. You multiply by -1, gets flipped around. So just to draw those 3 examples, let's say this is vector A. Then this one here will be vector 2A. Yeah? And then this one here, a half A. And this one here, what's this one? Minus A. Okay, you don't need to write this down, but I think it would be nice if you could draw this as examples. So if you could just draw this one. This is vector A, so then this is vector 2A, this is vector a half A, and this is vector minus A. Yeah, can you draw that?
So the minus is the opposite direction.
Yeah, just flips the direction around. What would minus 2A look like? Would look something like,
Bigger, but
yeah, bigger, but the other way around.
2 times.
2 times it, yeah. Yeah. We're happy with that? Yeah? Okay, so, of course we can plus, minus, multiply and divide scalars. Can we multiply or divide vectors by a scalar? Yes, we just looked at that. Can we add or subtract vectors? Yes, we use the vector triangle. We cannot multiply two vectors. Well, not yet anyways. We'll talk about that later. And we can never divide a vector. So it's, you know, if I have vector A, and let's say this is vector B, you can do this. Happy. You can do this. That's fine. You could do this. That's all fine. What you can never do, never, ever, ever, A divide B. You can never do that. You can never divide vectors. Okay. Right. Here's another example. Again, I'll ask you to draw this. I give you two vectors. Now look carefully. Vector A is 5 kilometers east and vector B is 5 kilometers per hour north. I want you to draw these, then tell me if you can add them, and then so on. So I'll just give you a minute to try this before I do it. Let's see if you can figure it out. I see some serious thinking. Confused? How far did you get into it? Which part? So what do you think? Can they be added or not? Let's have a look at it. Let's have a look. So firstly, draw the two vectors. Fine. So here we go. This one, no, sorry, A is 5 kilometers east, so that could be A. And then B is 5 kilometers north, so that could be kilometers per hour north. That's part A. Whoops, dear. That's part A. B, can they be added together? Yes or no? What do we think? Decision time. What are we going to say? You got a 50-50 chance. What do we think? You say no? Okay. Anyone say yes? Only have one person telling me no. Okay, why'd you say no?
Because A is working on distance, but B is speed.
Correct. The units are wrong. So the answer is no. It's the wrong units. So you can't. Very good. Very good. Okay, C. Consider the vector TB, where T is 2 hours. What's the dimension of TB? So what's the dimension of TB? Well, what's the dimension of T? T is measuring what? 2 hours, so it's measuring time. And what about B? That is a length over time. Yeah, speed. Well, in this case, a velocity, but anyways, you get the idea. So that's equal to a length. So what does TB measure? It's measuring a length. Okay. D. Draw TB. Okay, how's TB different to B? How's TB different to B? What's different?
2 times.
2 times it, yeah. So if that's B, then that's TB, 2 times it. Yeah? E. I want to add A plus TB. So you remember how this goes? You draw A, you draw TB, and then you add them together, and there's A plus TB, the resultant. Yeah? And the last question, what does this OR represent? What's actually happened here, if you were to imagine a story? Any ideas? Say again, yeah? Ah, yeah, but give me a little story. What's happened? Yeah? Yeah? Ah, so you're imagining a person went along here and went along here. Is this? Yeah. Nearly. Nearly. Not too bad. Not 100%, but not too bad. You have the right idea, but you're forgetting something about what A and TB are. So, look at it like this. What was A measured? What were the units of A? Kilometers. And what was B? Kilometers per hour. And what was T? Time, hours. Yeah. So if you think about it, what this is, it's like saying is a person started at A, 5 kilometers east. Then, for 2 hours, they travelled north at 5 kilometers per hour. So what this is representing is somebody who started here, because A was in kilometers, it's a displacement. It represented where they start. Then you add to it this distance. This distance you got was from 2 hours time multiplied by a speed. So what this picture was representing is a person who started here and went here. So you nearly had it, but not quite. If this A was kind of like this, if this A was something like a TA, then you could say they travelled here for some time and then travelled here for some time. But in this particular story, they went from here up to there.
So then A doesn't mean like.
Yeah?
What does A mean then?
It's their starting position, where they started. So, people don't have to start from the origin. In this story here, it's like we're saying this person is 5 kilometers east of the origin, and then they began to walk north for 2 hours at 5 kilometers per hour. Yeah. Now don't worry too much about that. The reason I'm talking about it is I want to show you that a simple little equation like this can give you a story. there's a story here of somebody starting at A and walking for t time at a speed of B, a velocity of B. That's all I'm trying to get you to see. You can get a lot of information in a little piece. That's what I'm getting at. Okay, continue. Yeah. Okay. A man walks 5 steps north, then 5 steps west, then 1 step east, and then 1 step south. This took 9 seconds. Okay, let's draw this. Now, to make my life easier, I'll make boxes. Oh, come on. How does this work again? Uh-oh, that's not it. Oh, I'll just draw it roughly. 1, 2, 3, 4, 5, 1. No, 1, 2, 3, 4, 5. Okay, let's do this together. A man walks 5 steps north. So we'll imagine he starts here, and then he goes 1, 2, 3, 4, 5. Okay. Then 5 steps west. 1, 2, 3, 4, 5. Then 1 step east. And finally, 1 step south. So actually, let me just try and loop that a little bit so you can see it, and then 1 step south. And he finishes here. Okay, fine. This took 9 seconds. 9 seconds. Right, let's do this one together. So my first question to you is, what was his speed? So here's the picture, and I want to know, tell me his speed. So I'll give you 1 minute to calculate his speed. All the information is on the picture.
12.
Yeah, good. 12 steps over 9 seconds, which is 1.33 steps per second. Okay, we're happy with that, right? Okay, B. Draw the 4 velocity vectors. So first, what did he do? He went north. So that would be like this one here. Yeah. That's the first one, the first velocity. And then here, that's the second one. Well, how do I want to draw this? I don't really know their length, so what length do I want to give it? No, I guess I'm okay. I'll keep it with that. 1, 2, oh jeepers, 3, 4. They're his 4 velocities. So first he's walking north, then he's walking east, west, then he's walking east, then he's walking south. Yeah? Okay. Alright, that's B taken care of. C. Draw his 4 displacement vectors. Okay, so first he walks north, and then let me draw it in. What colour will I use now? Black. So first he's here, but then he changed direction, and then he is here. So we remember displacement is from the origin. So we need to draw it like this. Okay. Then the next one. And then the last one. Getting a bit messy now. They're his 4 displacement. Displacement vector points to where he is. Like follows him, you know. Okay, D. What is the magnitude and direction of his final displacement? Okay, so the final displacement was here. What angle or what direction is this? Now look, 1, 2, 3, 4. 1, 2, 3, 4. So what angle is this? 45. So what direction is that? North, west. No, northwest, yeah. So we know the direction is northwest. But we need to know the magnitude. So we just need to know this length. I give you a little hint too. I said a right angle triangle with sides 4 and 4 will have longest side of 5.65. So I gave you the answer. It's northwest, or rather I should say, it's 5.65 steps northwest. That's his final displacement. Okay, that was D. And lastly, E. Now I want you to try E before I do it. What is his velocity? What's his velocity? So think back to the formula for velocity. What's the formula for velocity? I think it's like total displacement, something like, or displacement over time. Yeah?
Change displacement.
Yeah. So, what's his average velocity? What is it here? Yeah, is it, yeah? Oh, don't be so shy. No. I'm a friendly teacher. You can tell me. What do you think it is? Yeah? Yeah? Okay, so you got 0.622. 628, yeah, and you got the same number. So you probably both got it the same way. What did you do to get that?
Delta X over delta T.
Yeah. So what numbers were that?
Root 32 over 9 seconds.
Yeah, the 5.65 over 9. Now, why did you say minus? Yeah, so you have the right idea. You need a direction, but it's not quite minus, because minus is usually just left or right. So what number did you say it was? I think you know. Do you know now what the... So close. Northwest. The direction is northwest. Here's the displacement, and you just have to divide that by 9 seconds. Oh, sorry, steps per second. Yeah, northwest, it's velocity. Yeah. I've seen this question in the exam a long time ago. It was an example with a boat. So that the boat go north and the boat went west and so on. So it's not too difficult if you've seen it before.
But this is also assuming the velocity is constant.
Yeah, that's why I put in brackets the word average here. So often in physics, when I ask you to say what is the average blank, you imagine that the blank is a constant. So here, it's almost like we imagined he headed northwest at 0.628 steps per second, and after 9 seconds he went from here to here. So a lot of times in physics, when we say what is the average of something, we imagine replacing it by a constant value that does the same job.
Then you have to like count how many seconds you lose on each corner and blah blah.
Yeah, so like this average velocity shows you how inefficient this journey is, because at the beginning we worked out he was going at 1.33 steps per second, but because he keeps changing his direction, his average velocity is only 0.62. So it's like he's wasting half his effort. Yeah. Continue. What have we got? Right, the last thing to say is vector addition is commutative. What that means is if you have vectors A and B, the addition you can commute, meaning A plus B is the same as B plus A. Yeah? but I think that's pretty obvious. You know, if you have A plus B, then you'll get this. Or if I say B plus A, then you also get that. Because it's the only difference is how you make it. Here, come on, need a new writing pad. This is A and this is B, whereas here, this is A and this is B, but it doesn't matter. You get the same result in the end. Okay. Right. So maybe I don't know. Maybe that's a good word for you to know. If you say something commutes, it means A something B equals B something A. Okay. Can you open up the workbook? How many questions did I give you in the next exercise? Or rather, how many exam questions are there for the next one? 6, is it? Can I have a look? How hard are they? They might be easier than the first homework. Let's have a look, see. You have them open? Yeah. Oh yeah, the first one looks okay. Ah yeah, 6 questions. But some of them are very short, like the first one. First question, what